Hello, in this session we will talk about what is Hadoop. This is Hassan Mir from 02protraining.com. So what is Hadoop? It is a framework of tools. It is not one software that you can download on your computer and say you have downloaded Hadoop. So what is this framework used for? The objective of these tools is to support running of applications on big data. Hadoop is open source set of tools and it is distributed under Apache license. So this guarantees that no particular company is controlling the direction of Hadoop and it is maintained by Apache. So we understand that Hadoop is a set of tools that supports running of applications on big data. So the keyword behind Hadoop is big data. Big data is creating challenges that Hadoop is addressing, and challenges are created at three levels. Lot of data is coming in at very high speed. Big volume of data has been gathered and is growing and growing and growing, and data is of all sorts of variety. It's not an organized data. It has audios, videos, files, log files, so on. Now, in a separate video, I have talked in detail about the challenges the big data is creating. In a traditional approach, an enterprise will get a very powerful computer and it will feed in whatever the data is available to this computer to crunch the numbers, and this computer will do a good job, but until a certain point, a point will come when this computer will not be able to do the processing anymore because this is not scalable and the big data is growing. So traditional enterprise approach does have its limitations when it comes to big data. Hadoop takes a very different approach than the enterprise approach. It breaks the data into smaller pieces, and that's why it's able to deal with the big data. Okay, breaking the data into smaller pieces is a good idea, but then what? How are you going to perform the computation? It breaks the computation as well down into smaller pieces, and it sends each piece of computation to each piece of data. So the data is broken down into equal pieces so that the computation, these child computations, could be finished in equal amount of time, and once all these computations are finished, then their results are combined together, and this is what is sent back to the applications as a combined overall result. So how is that Hadoop able to break the data into pieces and computation into pieces? At a very high level, it has a simple architecture. You can say Hadoop has two main components: MapReduce and the file system. The file system is called HDFS, Hadoop File System. As already mentioned, Hadoop is a set of tools, and let's call those set of tools as projects. There are numerous projects that have been started and managed by Apache under the umbrella of Hadoop, and the objective of these projects is to provide assistance in tasks that are related to Hadoop, and we will touch base on these projects very soon. But keep in mind that besides MapReduce and file system, there is another component to Hadoop, and let's call that projects. One important characteristic of Hadoop is that it works on a distributed model. We are not talking about one big powerful computer. We are talking about numerous low-cost computers known as commodity hardware. Hadoop is a Linux-based set of tools, so we have Linux on all these low-cost numerous computers. All these computers will have two components of Hadoop: task tracker and the data node. The job of the task tracker component is to process the smaller piece of task that has been given to this particular node, and the job of this data node is to manage the piece of data that has been given to this particular node. And all these computers will be called slaves. Why would they be called slaves? Because we have a master. And what's the difference between the master and the slave? The main difference is the master will have two additional components that are running on the computer. It would have task tracker and data node as well, just like any other slave computer, but additional to those two components, it will also have job tracker and the name node. So we have learned that Hadoop has two main components at a very high level: MapReduce and the file system. How does that relate to the job tracker and name node and task tracker and data node pieces that we are talking about? So the job tracker and task trackers, of course, are part of the high-level component MapReduce. So they all fall under the umbrella of MapReduce. And similarly, the name node and all these data nodes fall under the umbrella of Hadoop file system called HDFS. The applications that are running on Hadoop will contact the master node. One of the attributes of Hadoop is that it is a batch processing set of tools. So applications would assign or provide a task for Hadoop to perform, and it's going to go in the queue. Once the task is completed, application will be informed and results would be given back to the application. Keep in mind, there are certain projects that provide real-time capabilities to applications to get results back from Hadoop, but mainly it is a batch processing set of tools. So the role of job tracker component running on the master node is to break the bigger task into smaller pieces and to send each small piece of computation to the task tracker. So they will perform their smaller piece and will send the result back to the job tracker. Then it will combine the results together and will send the final result back to the application. And the name node running on the master computer or master node is responsible to keep an index of which data is residing on which data node. So when application contacts the name node, it tells the application, go to this particular computer to get your data. So it has all the index. So the name node tells application where the data is residing, then it goes directly to that node and will get the data directly from that node. So application is not dependent on name node to give the data back. It goes and gets the data directly, but it has to know where it is residing. The hardware failures are bound to happen. They will happen, and the good thing about Hadoop is that it is built keeping hardware failures in mind. It has a built-in fault tolerance. By default, Hadoop maintains 3 copies of each file, and these copies are scattered along different computers. So this way, when a computer fails, the system keeps on running. Data is available from different nodes. And once you fix the failed node, then Hadoop will take care of that and it will copy some other files to that node. So that is one of the very important feature of Hadoop file system, the fault tolerance. The fault tolerance is not limited to the disks failing at one of the slave nodes or even at the master node. It is also applicable to the task tracker services that are running on slave computers. If any of the computer fails or even just the service fails, job tracker would detect the failure and it will ask some other task tracker to perform the same job. The fault tolerance is there, but one can argue the fault tolerance is there only as far as the slave computers are concerned. If master computer dies, then that would be a single point of failure. Hadoop has taken care of that as well. The tables that are maintained by the name node that has all the index where the data is residing, on which computer the data is residing, all those tables are backed up and the backup copies are copied over to different computers. And enterprise version of Hadoop also keeps 2 masters, one as a main master and one as a backup master in case of master dies. So that is not a single point of failure. So we have talked about how Hadoop has solved the challenges provided by the big data, and we have talked about the architecture of Hadoop. This brings back to the bottom line. The programming is now very easy for the programmers. Programmers do not have to worry about taking care of where the file is located. The master node is there to manage that. And also they don't have to worry about how to manage the failures. Hadoop is taking care of that. And also they don't have to break the bigger computation down into smaller pieces. That is the task for Hadoop. It's going to break the computation down and will send the smaller tasks to the individual nodes. And also they don't have to do the programming for scaling. Whatever program they are writing for 1 megabyte of file will work for 100 gigabyte of file as well, because scaling is now a problem for Hadoop, not for the programmers. And the real bottom line is this: the programmers can now focus on writing scale-free programs. One of very important attributes of Hadoop is that it is highly scalable. An Hadoop system could consist of one computer, and it could go up to thousands of computers. All depends on the requirement and changing needs. So you can start with few computers. As your data is growing, you can add computers. And this results into tons of cost savings for the business. Important thing to keep in mind is the scalability cost is linear. So if you want to double the speed of processing, double your number of computers. So we understand that the MapReduce and HDFS file system are the two main components of Hadoop. We also said that Hadoop is a set of tools. It's not a name of one software. So these are the projects and tools that are managed by Apache. I have a separate video that talks about little bit history of Hadoop and how the credit goes to Google actually behind the Hadoop technology. But for now, I'm just going to mention here that in 2005, Hadoop was created by Doug Cutting and Michael Caffarella. Both used to work for Yahoo. And there is a little story behind the name Hadoop. Each of this piece of software is providing a value add at certain area related to Hadoop. There is a separate video that talks about the overview of each of these tools. So here I'm simply listing you the main projects that are related to Hadoop. Doug's son had a toy elephant, and he gave this name Hadoop to his toy elephant. So this is where the name is coming from. And in 2006, the project was donated to Apache. So now Apache is maintaining Hadoop and the related tools. Just like any other enterprise level application, the users of Hadoop could be divided into two groups: administrators and users. Administrators are responsible for tasks like installation, monitoring, managing the system, tuning the system, and in short, maintaining the overall health of the software. Here are some of the areas where Hadoop is being used in social media. Facebook is the second largest user of Hadoop after Yahoo, and then we have Amazon, for example, perfect example for retail. Financial services heavily use Hadoop. Search tools. Google was the one behind the Hadoop technology, but it is being used in other search tools as well. And government is a heavy user of Hadoop and related tools, and so is the intelligence agency. So any area where we are dealing with big data is likely to use Hadoop. And users are responsible for designing the application, importing, exporting data, and working with the tools. However, keep in mind there is no hard line between these two groups. So users do tasks regularly that belongs to administrators. For example, they closely work with admins to tune the system, and administrators do perform tasks that belong to users. For example, they work very closely with users to write applications to meet certain objectives and so on. So there is no hard line like we see in other enterprise level applications like ERPs, for example. Here are some examples of companies that are heavily using Hadoop. Yahoo, the largest user. Then we have Facebook and Amazon and eBay, American Airlines, the New York Times, Federal Reserve Board, Chevron, and IBM. There are few examples, but there are tons of other users. Some examples of the applications: mining of users' behavior to generate recommendations. Mahout is the tool that comes in mind. So this application belongs to the advertisement area. Then application of grouping related documents based on certain criteria. This is helpful in search areas. And then search for uncommon patterns to detect fraud behavior. This goes under the category of security, and so on. These are just few examples. There are tons of other applications as well. So how does the future looks like for Hadoop? This is what Yahoo says. By 2015, 50% of all enterprise data will be processed by Hadoop, and this is clearly because of the limitation of the enterprise model, where no matter how the big computer is, it will have limitations when it comes to big data, because the size of the data will come to a point where that computer will not have enough power to deal with that size. The key word is scalability. That is what is required. Now this is a job trend for Hadoop. Search on Indeed.com. You can see how the number of jobs are increasing exponentially. That has anything to do with Hadoop. So this gives you a clear idea of how much this technology is in demand.